Good morning. Today we're going to be talking about section 5.3 entitled Polynomials and Polynomial Functions. Well, as you may recall, let's define a monomial. A monomial is nothing more than a product. And the key word here is product. It's a product of powers, could be more than one, of variables, and it could be more than one, and a constant, sometimes referred to as a coefficient. Examples of monomials. X is a monomial. I can view it as a product of a power of a variable x and a constant 1, could I not? 6r squared is a monomial. Minus 15 x cubed y. There's two variables, but it is a monomial. It is a product of, well, kind of simply variables and constants. Any real number is a monomial, because I could refer to 7 as 7 times x to the 0 power. So all these I've listed are examples of monomials. Products of powers of variables and constants. Alright, once we define what monomials are, defining polynomials is easy. A polynomial is nothing more than a sum, or of course difference, of any number of monomials. Now some of these we give special names to, some of them we don't. 5x plus 3. That is a monomial plus a monomial. I call that a binomial. 4x squared minus 6x minus 8. That is a sum of 3 monomials, so I'll call that a trinomial. How about something a little more complicated? P cubed plus 3p squared cubed plus 3pq squared plus q cubed. Alright, so this is a sum of 4 monomials. I'll just call that a 4-term polynomial. Poly for Greek prefix for many. And of course mono is the Greek prefix for 1, right? Alright, so we've defined and gave examples of both monomials and polynomials. Let's talk about the degree. Well, let's first start out with the degree of a monomial. Alright, 6x cubed is a monomial. And if a monomial has one variable, the degree is the exponent on that one variable. So I would call this a monomial of degree 3. In other words, 6x cubed is a monomial of degree 3. Again, the degree, if it's a monomial and if there's just one variable, the degree is the exponent on that variable. Alright. How about something like this? Minus 4x squared y to the 7th. This is a monomial. It's a product of powers of variables and constants. Now, if there's more than one variable, in a monomial, then the degree is the sum of the exponents on all those variables. So here I would call this a monomial because it's a sum of one monomial. And I would call this degree 7. I'm sorry, degree 9. Degree 9. Because I can see the sum of the exponents is going to be 9. Monomial, degree 9. Alright, for example, 7, the number 7 is a monomial. And I would say that's degree 0. Because clearly I can rewrite 7 as 7 times x to the 0th power. So any constant is going to be a monomial of degree equals 0. Alright, so we defined what degrees of monomials are. Let's talk about degrees of a polynomial. The degree of a polynomial is the degree of the highest degree monomial it contains. That makes it sound harder than it really is. Well, for example, 2x plus 1. This is a binomial because it's a sum of two monomials. This monomial is degree 0. This monomial is degree 1. So the degree of the polynomial is going to be the degree of the highest degree monomial it contains. So I would call this a binomial of degree equals 1, the highest degree monomial it contains, right? 3x squared plus 2x minus 5. Well, here we've got a sum of 3 monomials. This constant minus 5 here, that's the degree 0 monomial. This x multiple 2x, that's degree 1, and of course this highest degree monomial is degree 2. So I will call this a trinomial of degree equals 2. The degree of a polynomial is the degree of the highest monomial that it contains. Try something a little harder. 3x squared y squared plus 2x squared y minus xy squared minus 3x. Alright, this is a 4-term polynomial. I won't call it a quadromial. I'll call it a 4-term polynomial. And if it was 5 terms, I'd call it a 5-term polynomial, etc. Alright, let me consider all the degrees of these 4 monomials. This is degree 1. This is degree 3, is it not? This monomial is also degree 3. This is degree 4. Right? So I'll call it a 4-term polynomial of degree 4. Okay. Hang on a minute. Alright. Let's go on then. Let me get a fresh screen. Alright, so we've defined monomials and polynomials. We've defined degrees of monomials and degrees of polynomials. Let's talk about evaluating some polynomial functions. We'll call polynomial functions. I'm confident that you are all familiar with function notation. Picture tells 1,000 words. This is a polynomial function. And of course, we read this as f of x, and we usually reserve the letters f and g and h for function notation. And really all that's happening here, x is a placeholder in this expression for whatever values of x I want to evaluate this function at. For example, if I say f of x is defined according to this rule, I'll say find, let's say f of 2. Well, all this means is wherever I see wherever I see x in my given expression, I'll substitute a 2 and evaluate according to my order of operations. Alright, so 2 squared is 4, 4 times 3 is 12, 12 plus 4 is 16, plus 1 is 17. So f of 2 is 17 for this function f of x as defined. Alright, let me erase this and get some room here. I don't want to rewrite the function if I don't have to. Alright, so same f of x as defined above. Let's find f of minus 1. Well, again, wherever I see an x, I plug in a minus 1. Now be careful when you're substituting in negative values. Probably a good idea to wrap them in parentheses so you don't mistake multiplication for subtraction, right? Minus 1 squared is positive 1. 1 times 3 is 3. Plus 2 times minus 1 is negative 2, plus 1. And 3 plus minus 2 plus 1 is, of course, 2. So f of minus 1 is 2. And again, same function. Let me substitute another value in for x. F of 0. Well, functions, typically polynomial functions, are easy to evaluate. Well, I should say usually easy to evaluate at x equals 0. Well, everything goes to 0 except for the constant term, so f of 0 is positive 1. Okay. Let's try another function. Again, we usually reserve the letters f, g, and h for function notation. G of x is minus 1/2 x minus 1. Now let's see, I'll compute the following. Find g of 2. In other words, evaluate the function at x equals 2. So wherever I see an x, I plug in a 2 and grind out my order of operations. Minus 1/2 times 2 is negative 1, and minus 1 minus 1 is minus 2. So g of 2 equals negative 2 for this function. How about g of negative 2? And again, when I plug in negative values for a variable, I usually wrap them in parentheses so I don't get mixed up. Minus 1/2 times negative 2 is positive 1, is it not? And 1 minus 1 is 0. So g of minus 2 for this function is 0. And how about g of 0? Well, minus 1/2 times 0 is, of course, 0. 0 times anything is 0. And 0 minus 1 turns into a minus 1. So for this function, g of 0 equals negative 1. Alright, so there's a couple of examples of evaluating polynomial functions as defined at certain stops along the way. I want to talk about adding and subtracting polynomials before we call it a day. And to add or subtract polynomials, well, all you really do is identify like terms and combine the like terms. Well, 6m to the 4th plus 3m to the 4th, of course these are like terms. The variable parts are exactly the same, the variables are the same, the exponents are the same, and if that's true, these are like terms, then I just add or subtract the coefficients as indicated. 6m to the 4th plus 3m to the 4th is 9m to the 4th. Alright, so the big secret here, when adding or subtracting polynomial expressions, well, basically we look to combine like terms to condense things as simply as possible. Let's try another one. 16 s cubed t plus 3 s squared t minus 6 s cubed t. S cubed t. Alright, you'll notice there's three terms. This is a trinomial. trinomial of degree 4, is it not? Alright, well, the idea here is two of these terms are like terms. Well, which terms are the like terms? The like terms are the ones where the variable part is the same, variables are the same, and the exponents are the same. So the s cubed t terms can be combined, of course, by adding or subtracting the coefficients indicated. So 17 s cubed t minus 6x cubed t leads me to an 11 s cubed t term. Notice this middle term doesn't combine with anything, so I've got to list it in my final answer and say this is as simple as we can get for that expression combining the two like terms. Let's try another one. Alright, well, let's see. What are like terms and what are not like terms? Right? The x term. I don't see any other x term or x to the first power term, so that's not going to combine with anything. And I believe these are all multiples of x squared. So all three of those x squared terms are like terms, hence I can combine them by adding or subtracting the coefficients as needed. So my final answer is going to contain an x. Minus 19x squared plus 22 is going to be 3x squared minus x squared is 2x squared. Adding up the coefficients of all the x squared terms, I get a positive 2x squared. Our author would probably give our answer in standard form. In other words, arrange terms in order of decreasing degree. So I would call this the standard form of a polynomial. Terms are arranged in what we call decreasing degree from left to right. But certainly, because of commutativity of addition, that answer is equivalent and just fine also. Alright, let's talk about some fractional values here. Let's say simplify the following polynomial sum. Let's get some fractions in here. 3/5 AB plus 4/3 A minus 7 plus 1/2 AB minus 1/6 A plus 4. Alright, so here I'm really being asked to add two trinomials, and you'll notice some of these are like terms. The AB terms are like terms that can be combined by adding the fractional coefficients. Alright, let me do that first. 3/5 AB plus 1/2 AB. Well, 3/5 plus 1/2 is really 6/10 plus 5/10, getting a common denominator, and that adds up to 11/10 times AB. Alright, that takes care of the AB terms. Notice, the multiples of A are also like terms, so just need to add or subtract those coefficients as indicated. 4/3 minus 1/6, we're getting a common denominator here. I'll have 8/6 minus 1/6, and that is 7/6. 7/6 times A, right? Don't forget to write the variable factor in your final answer. And now just the sum or difference of the numerical degree 0 monomials. Minus 7 plus 4 is, of course, minus 3. So there's my final answer, adding those two polynomials, 11/10 AB plus 7/6 A minus 3. Let's try another one. Add or subtract as indicated is an instruction you might see on test day. Let's start out with a binomial of degree 2. And here I'm going to want to subtract a binomial of degree 3. Oops, did I say this was degree 2? This is a binomial of degree 3. This is also a binomial of degree 3. And I'm going to want to subtract them. Well, I think you know where we're headed here. When you're subtracting polynomials, basically I take the opposite of the polynomial I'm subtracting and change all the signs and treat it like an addition. So just carry that negative sign through the polynomial you're subtracting and then combine like terms. 8x cubed minus 2x cubed is 6x cubed. Plus 2x squared plus 3x squared is 5x squared. So I've combined as much as I can. These are now unlike terms and cannot be combined. So once I've simplified as much as I can, this is my final answer. 6x cubed plus 5x squared. Alright, let me get a fresh screen. We'll do one more kind of nasty subtraction and we'll call it a day. Subtract or add as indicated. I'm going to have 3 polynomials here, so let me try to write a little smaller. That is a trinomial of degree 2. From that, I'm going to subtract another trinomial of degree 2. And from that, I'm going to subtract yet another trinomial of degree 2. Alright, the order of operation holds for polynomial expressions just like it does for numbers. Subtraction, which subtraction gets done first? It's the first one you see left to right, so I'll do that subtraction first. And forgive me, I'm going to be a little formal here. I'm going to actually write it out carrying this negative sign through this polynomial I'm subtracting. Minus a minus 4x squared is plus 4x squared. Minus 7x is plus 7x. And minus positive 2 is going to be negative 2. So essentially I just go through and change all signs of that polynomial that I'm subtracting. And I suppose I could do the same here. Subtracting a polynomial, take each term in that polynomial and subtract the signs, or change the signs, I should say. Alright, so I've dealt with the subtraction symbols, and now I'm just going to combine like terms. I see x squared terms, I see x terms, and I see constant terms. Alright, let me look for the x squared terms first. I'll get minus 2x squared plus 4x squared minus 4x squared. Well, of course, it turns into a minus 2x squared. And I take care of all the x squared terms. How about the x terms? 6x plus 7x is 13x. Minus 10x leaves me a plus 3x. Take care of all the x terms, right? Now the constant terms. 5 minus 2 is 3. 3 minus 5 is minus 2. So there's my final answer. Subtracting all those terrible polynomials gives me a relatively simple response of minus 2x squared plus 3x minus 2. Alright, we're reaching on 25 minutes, so we'll call it a day. This concludes section 5.3, Polynomials and Polynomial Functions.